Hi, I'd like to welcome all of you today to the Adapt webinar. Today we're going to be covering the Adapt wall design workflow in Adapt Builder. My name is Spencer Lee. I'll be conducting today's webinar. Excuse me. Just a few notes are that today's webinar will be recorded and placed on the Adapt YouTube website, so it's youtube.com/adaptsupport, and you can go and to that website and view the recording at your convenience. Today's webinar should last roughly an hour. We'll save the end of the webinar for some questions that are related to the content. If we can't or are unable to answer the questions, we can always take it offline and then answer questions, or if you request any technical documentation, we could send those to you by email. Also, if you do have questions that are specific to a specific model or troubleshooting or some problem you might be having, please either call or submit those questions to support@adaptsoft.com. So we'd love to help you, but just in this particular forum, it's probably better and more efficient to send those directly to support. So today we're going to look at creating just a very simple model. Again, the purpose of the workflow is just to show, or the webinar is to show the workflow of wall design. And I'll be using Adapt Builder 2017. The version that I'll be using today is actually Build 2, which is going to be released in roughly 1 week. This includes additional improvements and a few maintenance items that are required for just a handful of things that we've caught between Build 1 and also Build 2. So this particular build will look identical, I think, to the build you're using, which if you're using Builder 2017.0 or 0.1. So we'll go ahead and get started. Today's session, we're going to just use the RC capability. We're not going to model any post-tensioning. We'll just build a model in RC mode and set up the wall piers and then look at the design process or the code check process for walls. So we'll go ahead and enter the program using Adapt Edge and RC scope. And we're going to build, first thing I'll do is use the option for level assignment, and I'm going to just add a few levels here. So we'll do let's say 8 stories. We can go back here and rename these if needed. So this might be, for example, plane 3, just for consistency and to avoid any confusion in the naming scheme. We'll call this plane 2, which is the first elevated, and we'll have the base. Okay, I'll go ahead and save the model. And then I'll use my build toolbar here just to create some arbitrary, fictitious set of slabs, columns, walls, and so on. So we'll go ahead and just create some sort of a slab region. And I'm going to add just a few columns. I'll change the column size to something a bit more substantial. So we'll use a 20 by 20 column. We're going to have just a couple of wall groups in this case. So I'm sure most of you have had practice in modeling in the software. So I'll kind of breeze through some of these different options and the tools we're using to create the model. And we're going to have walls. We'll do 3 wall groups. So, or we'll call them piers, where one pier will just be linear, the other pier will have multiple, let's say, multiple wall legs. So here's a 3-sided or 3-legged pier, and then we'll do another pier over here that might have just 2 sides. And I'll go ahead and just add load to this base slab. So this is the first elevated slab that I'm working on. You can see here I'm working in single level mode, and we're working on plane 2. So all of the modeling and modifications I'm making apply to the current plane. And we'll add just some basic gravity load for dead and live. So this is superimposed dead, we'll say is 20 PSF, and superimposed live, we're going to use, we'll go ahead and use, let's say, 50 PSF. And then I'll take these components. Actually, let me add a couple of openings while we're at it. So I'll add an opening here. And I'll move this point just so it's aligned with that wall. And then the rest will be as is. I'll now take these components and loads. I can tell I've selected the loads if I rotate to a 3D view. Obviously they're displayed, so whatever is displayed and selected can then be copied, and I'll use the option to copy and move vertical, and I'll copy this up 7 times. And if I switch over to global mode now, you can see that the building has been essentially built for this particular example. I'll go back to my default display just to show the structure. So this is the structure we're going to focus on for the design. I will have a little bit of variance in the material assignments and the thicknesses. So I'm going to change the thickness of the walls in the first, let's say, 3 floors to 12 inches, and I'll go to 10 inches and then 8 inches because I want to show some of the colorization options that are available in the program. So let's go to the structural components display. I'll turn off the slabs and the columns and the openings, and I'm going to create 2 additional material assignments. So I'm going to leave the default concrete one as is. I'll just create this one. This will be 5,000, and then I'll do a 6 and a 7,000. And the reason I'm setting these up is just to show how they influence the design of the walls and how changes can be propagated when we go into the wall design process. So for 5,000, I'll change the compressive strength and the modulus. We'll do the same for 6,000 and the same for 7,000. This window may look a little bit different to you only because we have, again, this is build 2, and in our next release, which is Builder 2018, the main release, not the maintenance release, we will have the ability to do fiber reinforced concrete using this Becker steel fiber input. So that looks a little bit different than your window, but the bulk of just the general material properties here should look the same. So I'll now go and change the columns. The walls. I'll select the walls I want to change. I'll use modify item properties, and if we go over here to wall, I'm going to change the thickness to 12 inches, and the material I'll change to concrete 7,000, and then I'll do the same thing for the next group. I'll change this thickness to, let's say, 10 inches, and the material will change to 6,000. And the same thing for the top. So this thickness remains the same, but we will change the material to 5,000. Now, something that is new to Builder 2017 that you may or may not have used this. If you go into the result display settings window, the red eyeglasses, which it's informally called, you go to Colorize, you can see that there's some colorization options here. These will be expanded in later versions to include more components and more design checks and so on. But here, if I look at the wall thickness, this just shows me a colorization of the different thicknesses that are assigned. I can also use this for material assignments and peer labels. Peer labels is blank right now. It's basically set to none. I haven't defined any peer labels yet. You can do the same thing for wall design sections. So once we define our design sections, we can colorize based on thickness, material, zone lengths, zone rebar patterns, patterns and sizes, and so on. Any wall that has similar characteristics relative to these options would then be sorted using the colorization. And it just helps to go back and review kind of at what state the current wall material and thickness definitions are, and also the wall design state that you're currently at. Okay, so we have our walls set up. We're going to introduce a few lateral loads to this model. I'm going to just use seismic loading. I'm not going to use wind for this example. I'll pick one, and I have less combinations to deal with when I look at seismic based on the load combination input file that I'm going to use. So I'll go here to loading, add load, seismic load wizard, and I'll add an X direction earthquake load. I'll just use the default parameters. I will change the R factor to 4 just to get some more force developed in the stories. But we'll just use the defaults minus this R factor, and we'll apply that. And then I'll change this to Y direction and change the direction to 90 degrees and apply that. So we have just two basic load combinations for seismic. And you can see if we go back to loading, load case library, those are added to the building load block. So we have to solve those two load cases in global mode in order for them to be solved and recognized in load combinations. That's necessary when we define building loads. If I go to the loading load case or load combination menu, you can see the program is just defaulted to some load combinations that are set up for the selected design code that we've selected in criteria. And we really haven't selected it. It's just some default selection, which is ACI 14 or 11. Here I'll just change it to 14. And that doesn't really do much for us. We have just, again, the same default load combination. So one of the questions we receive a lot is how do we develop load combinations for combined gravity and lateral effects, or for lateral effects once we introduce new load cases? Well, the program requires the user in its current form to develop the load combinations, at which point the user can save that as a template file or export import as an IMP file. And in this example, I'm going to import an IMP file to develop or to write in more combinations for lateral and gravity combined. So I'll go here to File, Import. We're going to import this generic adapt file. And I'll go ahead and just find the file that I've exported out of a previous model that had the load combinations created. So I'll just use this one called master loading ACI. When I import this file, I want to make sure that I update the model. So we're going to use the option to update. I'll turn off merge similar slabs. I want to deselect updating components because my ultimate goal here is to just import combinations, not any component update. So we'll deselect all. I'll import none of the load cases because that will import, applied loads from the IMP file. We only care really about this importing of load combinations. So I'll go ahead and I'll import all of them. And you can see there are several that include wind. That's okay. We'll just import those in and then delete them to sort. You can see I get a warning saying that I already have 4 combinations that are being imported in. These 4 are already included in the model. Do we want to override them? So we'll say, yeah, we'll override and write over those. And now I'm left with, if I go back to load combinations, I'm left with, well, I should have been left with several combos. Let me try that again. This may not, well, I may run into a few problems here only because this is, let me see, this is builder 2. So this is yesterday's build of the software, and again, that's an internal version, and we have been working on more IMP improvements in order to allow us to link with other programs like Tekla Structural Design and some international programs. So let's see what happens. I'll try this one more time. If I'm unable to import this, then I'll just go ahead and create them manually, just a couple of additional combos. Okay, I'll deselect there. And let's try this again. So this sets this to yes for all of the options. Yeah, so that's for some reason that is not working in this latest internal release. So that's fine. Let's go ahead and just create a couple of additional combinations here, just for the sake of the workflow example. So we'll go and select this combo. I'm going to just add 4 additional combinations. I'll set these all to strength. Okay, and we'll add some factors here. I'll just use 1 again, just for the sake of simplicity, and I'll use 1 for my my dead load. I'll factor up, let's say, live load, or maybe 1.6. And I realize these aren't probably code accepted combinations, but again, they're just for example. And then for EQX, I'm going to use a 1 and a -1 just to reverse the direction. And here I'll use, let's say, 1 and -1. So we have just 4 additional combinations that that we've created. We could rename these. I'll call this strength 1. Well, let's be a little more descriptive. Strength EQX positive. And this will be strength EX, let's say, negative. This is strength EY positive, and then strength EY negative. We'll say OK, and I'll save the model. Okay, the next step, so we have our model, we have our loads, our combinations developed, and at this point now we get into some new ideas or new processes if you're not familiar with the wall design. So the first thing we have to do in order to generate and establish wall design sections, we have to define wall piers. And there is a question. Let me go ahead and see what that is. The question is, can we import load combinations directly from Etabs to Adapt Builder? You can. The program, in order to do that, we have a separate tool which is called the Adapt Integration Console, which is this program here. And the first thing you have to do is you have to run the Etabs model through the integration console. That will allow you to write geometry, applied loads, and reaction data to a file. It's just an IMP file, and then you basically import that IMP file, suppress the geometry and the load cases, and you might just want to import the combinations. So there's the availability to do that with this integration tool. This is a free program. If you're interested, if you don't mind just sending us an email to support@adaptsoft.com with your contact information, we'd be happy to send this program to you. So that is how you could exchange data with Etabs. So I was showing or mentioning before the question that in order to design walls, you have to define piers. So we're going to go ahead and I'll go to a top view. Notice that I'm in global mode. So I'm in global mode right there, and I'm going to just select and define piers. So if I select this set of walls, and I'll go to FEM, pier labels, and I'm actually going to add 2 more pier labels. So we'll do pier 2, and we'll do pier 3. We have 3 piers. We're going to call this first one pier 1. I'll assign it. I'll go back, and I can assign through FEM pier labels like I did the first time. I could also select a peer group and assign through modify item properties. I can go here to to wall, pier, and this would be pier 3. So it's similar to column design group in this sense, where you can assign it through that. Now there's another question. Let me see what the question is. Question is, can you modify combos in the IMP file, or is it simply an export from Edge where one has been created? You could, Pavel, you can, if you create the file, you can open the file like in Notepad or some other editor, and you can manipulate the file before you import it to import it into Adapt, into Builder. It requires that you have to maintain the format and the syntax for the IMP file, but you can manipulate and generate it or make changes to it. So the file, I mean, if you look at the file, while we're talking about that, if I open an IMP file, and here you can see there's just several blocks of data listed. There's level assignments, materials. Here's my combination block. So if I come in here and I say, well, I want to create inside of this text file a master set of combinations, you certainly could come here and just write the combinations here, change factors and save it, and then that would be the data that is imported into Builder. So this is just the file, the IMP file format. Excuse me. So if I go back to analysis, and we just assigned piers 1, 2, and 3. I'll just display the pier labels, and I'll increase the text size because I can't read those marks here. So I'll increase this maybe to 12. Let's apply that. Maybe go a little bit higher. Say 24 and apply. So there's pier 1, 2, and 3. And those pier stacks are identical for the entire stack. They're the same pier number. So this allows me to do two things. One, it allows me to create reactions for the entire wall group. In previous versions of Adapt, each wall was reported in terms of its axial force or moment or set of actions. They were reported independent of each other. They were analytically considered as a group, but reporting-wise, we always reported them independent. In this sense, if you define piers, you can extract pier reactions at the centroid of the pier group, and I'll show that when we analyze and solve for this. So we've defined our pier assignments. The second step for wall design would be to generate the wall design sections. So the program will, once you've defined your piers, the program develops design cuts at the top and the bottom of the walls. And you can see, for example, we have, this would be like pier 3, whatever this wall number is, the nomenclature is the wall number. Let me use a thinner pen. So the nomenclature is wall number. So let's say this is wall 1, this is pier 3, and this would be top or bottom. So in this case, it's bottom. So that's one design cut for pier 3 at the very bottom. And then you have another design cut here that's evaluated, and a third design cut here. So there are 3 design cuts at the bottom and 3 at the top of this lower wall. And we just repeat that vertically for each unique wall ID. So this is wall number 4. This is wall number 10, and so on. So if I go to the Wall Design Manager, where I can manage the reinforcement that is located in these walls, that's under Wall Design. If I go into the Wall Design Manager, you can see for Pier 3, if I go down here to, I missed one step. This is level 1. It's not wall 1. It's level 1. So this is like level 1, bottom of wall 2, bottom of wall 3, bottom of wall 4. This is the section that I just referenced. Let me erase my drawing and select that. Let's see, level 1, bottom of 4. So do you see it? It highlights that wall. If I go to level 1, bottom of wall 3, that's this leg. Bottom of wall 2 is this leg, and then I can also do top of wall 4, which is here. There's 2, and 3. So this is how the design cuts are actually generated. So before you actually process the design of the walls, it would be necessary for the user to go in and determine, what's my base level of reinforcement in each of my walls. And in this case, we'll look at wall stack 1 for an example. In wall stack 1, so it highlights this section over here. You can see it's red. For that particular wall design section cut, I'm expecting to see an image here, but I don't see an image. And the reason I don't see an image is because I have multiple sections selected. So if I expand out 3, you can see I still have this selected. Now I only have one section selected, which is here. Now I can review the reinforcement that's currently defaulted to for that particular wall section. So the program reports the geometry, the zone length, the total length, zone 1, zone 2 on either end if you have to consider boundary elements, panel reinforcement. The program allows you to input reinforcement for each one of those wall sections, let's say. So for vertical bars in the panel, we default to number 4 is at 18. Maybe I want to change that to 12. Number 4 is at 12 are the horizontal bars. And I might want to use a number 5 bar in the panel. That updates this view. You could have anywhere from 1 to no panels. If I turn this to 0, you can see the bars in the panel go away. Obviously, if I increase, we're going to add more reinforcement. So this controls the panel reinforcement. Let me go ahead and answer a question. The question is, can you say how zones 1 and 3 are determined, or zones 1 and 2? So by default, the program defines the zone length depending on your design parameters. So if I go over here to design parameters, you can see that the design tool that we default to is called Adapt Wall. There are basically 2 wall designers that you can choose from. One is Adapt Wall. That's just our native wall designer. It's simplified, so it really only supports the ACI code currently. It supports prismatic wall sections. So if you have a wall that has boundary elements that are of different thickness than the actual panel, then you're forced to use the S-Concrete design tool, which is also listed here. I could switch over to S-Concrete as well, and I'll talk more about that in a moment. But for the Adapt Wall Designer, we support only ACI 11 currently. S-Concrete contains multiple design codes that you can choose from. When you go to S-Concrete, you also have to choose a template file. The template file is an input file for S-Concrete that defines the design code and other parameters that are not expressly, let's say, designated in this input. So there are several shared parameters that we use between S-Concrete and Adapt Wall, like the length of the wall, the zone length, etc. And those shared parameters are written directly from Builder to S-Concrete when S-Concrete is the design tool. Other parameters like, let's say, seismic design requirement inputs, things that Adapt Wall cannot handle analytically or design-wise, those are set in an SCO template file. And I'll show you how to set that file here in a moment. Back to the question, how do we determine zone length? Well, in Adapt Wall, if you turn on the option for check boundary elements and you select this as no, you'll go back, notice that the zones, really, I can turn off the zone requirements. So that first of all unlocks the zones, number 1. So here we're just left with panel reinforcement. If you decide to include zone reinforcement, the dimension of the zone is really controlled by the number of curtains, which are these 1, 2, 3, and the number of the face bar spacing. So the face bars, the face bar spacing is really the dimension between here and here. This is 9 and 9, and then the cover is designated also inside of the input parameters here. So the cover right now shows 0.36. I'll change it to 2. And so that determines the zone length. There are some other inputs that are also associated with the zone length that are just design requirements and, let's say, limits that are designated by code that the program will interpret and follow in checking the zone. Can we customize the zone sizes? Yes. You can customize based on your input of the face bar spacing. And then Pavo, you asked, so those are boundary zones for high seismic, and the answer is yes. For high seismic, again, you're forced to go to S-concrete because that allows you to designate the input parameters for high seismic boundary zones for the wall design. And again, I'll show you what that looks like. So let's do that now. Let me close this dialog for just a moment. And I'm going to just save the model. I'll run over here to S-concrete. Okay, and you'll notice in S-concrete, I have these shaped like C-shaped, T-L-shaped wall groups. Those really must be used independent of Adapt Builder. So if you're trying to design a wall that is a composite group type of a design, our program always designs linear legs of wall groups. So if you have a C shape, remember it breaks that C shape up into three design cuts, top and bottom for each level. So everything that you do between Builder and S-concrete in terms of linking this program to use as the wall design module, you're really working, excuse me, in this mode of a linear wall with or without these boundary elements. So this might be our SCO template file where you have zone A panel and zone B. Inside of this, you can go into edit section or edit reinforcing, and you can determine, additional seismic parameters that may not be written inside of the actual Adapt Builder interface. So any parameter that is not defined in the input of Adapt Builder would have to be defined in your input, your template file for S-concrete. For example, the design code. Here I want to say, well, I don't want to use ACI 11, maybe I want to use ACI 2008. My seismic design category, let's say, is D, and I have additional options here that are written inside of this file, not inside of Builder. So this becomes my template file for the design of walls that I'm trying to process in the program. So I'll say okay there. Other options, if we go into reinforcement, there are some other options here that would be applicable to the template file that are not written also inside of Adapt Builder for zone reinforcing, zone A and zone B. Let me go back to the questions. Question is, does this include the Indian code 456 or 13920 for wall design? That's a good question. I honestly don't know. Let's take a look and see what that looks like. If we go out of this and I go back over to the section. So these are the current design codes that are supported between S-concrete and Adapt Wall Designer, and it does not look like it currently supports that. I do know that there was a request from our international team for future development of Indian standards for column design, and that I believe would be extended out to wall design. But currently, these are just the design codes that are used within this program. I'm going to change this to U.S. units. Okay, so I'll just go ahead and save this, as my template file. Now notice I didn't really do anything with the geometry because the geometry data is written from Builder into this program. So if I have a prismatic wall that is the same thickness along its length, then I don't really have to change anything geometrically. If I do have a seismic wall that has different thicknesses between zone A, B, and the panel, then I would have to design, or let's say define, the thickness for the zones as an explicit setting within the template file. So I would have to go in and change that geometry here in order for it to be interpreted when I select this file to be used using the S-Concrete module. I'm going to go ahead and save this, and I'll call this just webinar. I'll close this file. We'll come back to it. So going back to FEM, column design options, or excuse me, wall design options, not column design. Should be under here. If I go to design parameters, I'm going to choose S-Concrete as my processing tool for design. It says select an SEO template file. I just created that file, so I can come here and select the SEO file, webinar. The design code is as defined in the template file. I have a utilization factor if I wanted to reduce that to like 0.9 or whatever. You could modify this utilization. The section type is rectangular or an I section. So if it is an I section, then that expands out some zone characteristics here. And this gives me the option to actually write in those dimensions. I didn't realize that was was actually in this input. So earlier I mentioned you have to define the width inside of S-Concrete. That is not true. You can actually define that here for zone length and zone 1 thickness, and that gets written geometrically into that file. So that's just a correction. The program, the overall wall height has to be input here. This is the building height or the wall stack height. The unsupported wall height, this is actually written by Builder to S-Concrete, or you can override it using this input. And then we have additional property assignments for vertical bars, horizontal bars for the panel and the zones. Design constraints, you can see the design optimization tools are locked out when you select S-Concrete, so those all have to be specified again in the template file, and the automation actually has to be done using those template file parameters. So let's just update that, and I'll close this for a moment. Let's get a processed or a solution here for the global model before we continue. So I'm going to go ahead and mesh this. I'll mesh it fairly high, 5 feet. And we'll go ahead and analyze the structure. And I haven't made any manipulations for stiffness modifiers or anything like that, or releases. I'm just designing as is. So we'll go ahead and analyze this using the uncracked stiffness, knowing that we might want to make changes to some of those options if needed. This is a great time for questions during the analysis runtime, but now it's moving, so maybe it's not a great time for questions. Questions anytime, really. So we'll go ahead and say yes to save the the solution. And first thing before we go back to the wall designer is reactions for the piers. If I wanted to look at the pier reactions graphically or in an Excel format, I'll go here to pier, and for example, if I look at the axial load for the pier, this is the axial load for that entire pier group. It's not just one wall leg, it's the entire pier group at the centroid of the or geometric center, let's say, of the pier. So you can see that the program reports this graphically. If I actually show a plan view, it will actually report the value. That looks kind of ugly, but you can see that this line, this mark, is really the centroid of that pier group, where the program reports the numbers. You can also, see shears, moments, and so on for the different peer groups. You can also report this in an Excel spreadsheet format, which is probably more useful. So we can go to reports, XLS reports, peer reactions. The program asks you which combinations you want to produce this for. I'll just select one to reduce it down. You can rotate and create resultant sets of forces based on the rotation angle for the peer group. But here we'll just say it's 0 degrees. There's no rotation, and the program will then dump out an Excel spreadsheet. It has several different sheets associated with it that give you geometry and so on. So this is just the cover sheet showing units, analysis mode, usage case. So these are like the Pier 1 properties. The Pier 1 goes from base to level 8. The CGX, CGY, that's just center of gravity for the peer group. The CG for the Z direction, top and bottom. Area of the peer group, moment of inertia about the two local axes, or the two main axes, and then how many walls are included within the peer group. Well, Pier 1 only has one wall, and it includes these walls. And then more properties. Here we can look at reactions. So these are the vertical reactions, shear moments for the wall group at the top and bottom of the pier. And then we go into Pier 2 properties and reactions, Pier 3 properties and reactions. So this might be useful for foundation design. If you're trying to design the foundations in a different program, you could use these reactions for the design of the entire peer group versus having to enter individual column or wall stack, let's say, forces. Okay, so that's peer group actions and, again, labels. So we now go back to our wall design manager, and I'm not going to spend a lot of time just changing, wall reinforcement. I'm going to go back to Pier 1. If you want to modify pier reinforcement for multiple sections, for example, if I wanted to use, let's say, number 5 bars at 12 for all of these sections, I can just change them at once. So here I can, use 5s at 12, 5s at 12. I can modify zone reinforcement if needed, and then I can update those individual sections. If I go and select single selection, then I'm only able to select one section at a time. But you can see this is 4s at 18. This is the default. If I go to the section below, this is the 5s at 12 that I just changed. So you can change single or groups of reinforcement. I can also copy and paste. So if I copy reinforcement from this section and I go to level 3 section and I say paste, that updates this section for that reinforcement also, then I would update. So there are ways to kind of manipulate the rebar in these groups. So we have two modes of operation. It's similar to column design. You can either code check or you can design the walls. So for example, I'll just do the very base section for this wall stack. Again, you want to make sure you define your wall parameters or your design parameters, your load combinations. This is the setting for whichever load combinations you're wanting to process. And if you have multiple solutions that are available. So if I was to have set up this model using usage cases 1, 2, 3, 4, 5, and I ran all 5 usage cases, which are basically just stiffness profiles, the program would store those 5 usage cases, and I would have the ability then to select which solution I want to use for for compiling the reactions necessary to design for these combinations. In this case, I only have 1 usage case. I've only run this model 1 time, which was uncracked global. So you can see that's the only thing available at this point is uncracked global. The option for tributary loads would also be available to the user if you had run tributary axial forces for the walls. We get into axial moment diagram, like interaction diagrams, and then also wall intersection. Wall intersection shows us schematically how wall joints are laid out when we get into the layout of the reinforcement. And I'll show you that also here in just a sec. So the first thing we'll do is we'll process, let's say, just a code check for this one section. And remember this, because I've selected S Concrete as my design tool, we need S Concrete as a licensed product on the machine. And you can see once that has finished, you can see the program will update the status. There's a warning associated with this section. If I wanted to, I could also show the shear torsion utilization and axial moment utilization as a status check. So I look at this and I say, okay, I wonder what the warning is for. That kind of signals to the user we need to check that out. I can immediately go to the design summary, and this shows me the output, which is again is similar to column output because this is the output generated by the S-frame program. And we have this status as a warning. So I'll just navigate down, and there's a warning message here, 57, 65, and down at the bottom, the center-to-center spacing doesn't meet the code requirements, and it gives you a clause, and the diameter of zone links does not meet the minimum size required. So if I say, okay, well, I can either manually change that on my side, or I can just design the section. So if I design the section, then the program would potentially, make changes to the spacing of the rebar that was not in code compliance, and also the diameter size or the size of the bar that was also not in code compliance. So now I'm changing gears and I'm just designing the section to see what happens. So obviously the program has made those modifications, and it's come up with a different design based on the code that was selected. So again, I could go back to design summary, and here we have our updated design summary. Now I didn't go in and look at exactly what the sizes and the spacing were that were triggering the warnings, but just showing you that the difference here between design and code check. So my recommendation is for the user to become comfortable with, first of all, code check. I would always recommend a code check first, determine what it is that's flagging the program to trigger the warning, make those manual modifications for the design sections, and then read code check to make sure you feel comfortable with how the program is handling your change that you modified in the design manager. And then you can go in and investigate some of the design options within the program. But this is one particular section, again, that has been designed. If we go to PM diagram now, we have this interaction diagram for moment axial, and I can show it should show the, let me see, the nominal and probable graphs. I'm looking to see for wall designer, and this has different theta angles that you can change for the orientation of the wall. If you go and use Adapt Wall Designer instead of Adapt or S Concrete, now I go back And let's say I want to code check that using Adapt Wall Designer. Now it's using a different set, let's say, of potential parameters that aren't included as part of the wall design package for this design. And those parameters are, again, defined in this particular setting inside of the Wall Design Manager. So that, again, is acceptable. The wall design summary sheet is just condensed. It's not as extensive as the S-Concrete design summary sheet. You can see here where we have some of the same input, but this also is reflective of the fact that some of the input parameters related to S-Concrete are not written inside of in the wall design, the native wall design input here. So that's what it looks like in terms of the design summary for wall design. If we go to the PM diagram, again, here we can show load cases. So this shows you where your load cases fall within the interaction curves for the wall design. And then the wall intersection, this kind of shows the different joints for the walls that you've selected. So for example, this is level 1. This is level 1, pier 1. This is the bottom section of wall 1. And you can see here I have 10 number 5 bars. This is how the bars would lay out. This is not extremely useful when you have just a linear wall without looking at a joint. But for example, if I went over here to pier 2, let me just expand that, see if we can bring up a joint. Let's look at zone 2. Yeah, like here, this shows you how the different bars lay out and overlap between the end zone of one wall and the end zone of the other wall. So this helps the user go back and detail this wall and let's say combine the two outcomes of two end zones that are basically designed separately. And then that would be shown really for any wall group that you select and location. So zone 1, zone 2, this is just the default zone reinforcement for these two design groups. Let me go ahead and close that. Once the walls are designed, and I realize we only designed one section, but once the sections are designed, you have the ability to go into under wall design status. This would show me a status check graphically of what the current status is for that particular wall section. So we have all wall sections except for one, which is shown here. The one that we just designed is okay. We can review utilization results for the cut for shear torsion. This is utilization for moment and axial. Panel reinforcement. This shows us all of the walls panel reinforcement. Now, this is, again, dependent on the setting for the size of the font. So if I go back and adjust that, now I can isolate this wall face. So if I say I want to isolate, I can right-click, isolate the wall face, and this helps me kind of view the wall a little bit differently. So let's go back. So this shows me panel reinforcement, and I could take and scale this down even further. I could select only this wall and then just display the selection of that wall. And here's one wall. I'll turn off the design cuts. So under let's see, under outline, I'll just turn off the outline. I don't know why. I think I'm on the wall. Let's see. Yeah, I'll look at that when we're done here. Zone reinforcement. Program will show the right and the left zones. And then you can also filter out some of the information that's shown here. If we go back to result display settings, we have the ability to show reinforcement display by number of bars, area. If I apply the area, that changes it from number of bars and quantity to just the total area of steel. I can look at it in terms of the reinforcement ratio between the bars and the zone area. Do we want to display text for the active level? Yes or no. So if I have the entire stack shown, let me go back to the entire stack. Let's see. Okay, I just turned on everything. I'll just reset the view here. We're looking at wall number, so we're looking at wall 1, so let me go back to this wall. I'll isolate the face, and going back to the, let's say, panel reinforcement, if we go and say display text for active level only, if it's set to yes, then only this wall information will show. If I say no, then all of the stack will show. So you can isolate the stack also that way. And then the section text for each wall, you can isolate top or bottom. So if I want to look at only the top rebar versus only the bottom rebar, that allows me to control those text outputs also. So this is more just for output of the wall design than anything. Lastly, for colorize, if we colorize the thickness of the wall sections, so I'll go back to this zone, you can see we have different wall section thicknesses shown here. We can colorize material, which is similar to what we had done earlier, colorize zone length, rebar, and so on. This allows us to make those quick graphical checks for consolidation and what is similar, what is not similar. If you change the thickness of the wall without having to regenerate all of our design sections, let's say in the design process you determine that the lower two walls need to be 16 inches thick, and you make that change and you change this to 16 and 16 here. Well, we need to go back. If I go back to the Wall Design Manager, and again, I'm going to look at this lower section. Okay, that's this section down at the bottom here. Under the design parameter, the section thickness shows 12 inches right now, but we had just updated it to 16. And let's assume that we reanalyze the slab. So anytime you make a change to the geometry or the thickness, you need to go to FEM and you need to update the wall section geometry. And by doing that, if I go back to the Wall Design Manager and again select the section at the bottom of the stack, this will update to 16 inches. If you change the material assignment, obviously that would also need to be changed inside of the input file to adapt wall. There is no current concrete material assignment here, so when the material assignment is changed and you reanalyze the structure, the program will carry over that material when we rewrite the data to wall and you reprocess or update the code check. So the material assignment is not selected here. Okay, so that's just a general overview of the workflow. Output in terms of Excel spreadsheets and PDF documents, you have the ability under reporting to go to wall design sections. So this produces, again, individual section reports for the wall design. There's also a PDF document or a PDF document that will produce the summary, a compilation of the summary sheets for the wall design. So this just shows the reinforcement for each pier, each plane, and each wall design section. Shows zone, panel, and reinforcement data and the current status. So right now there's only one wall that's actually been designed, one wall section rather. There's geometry. So again, for each design section, there's a geometry table. And also, you can see governing loads. So this would give you the governing load for the wall sections that have been designed. In other words, what produces the worst case interaction ratio for that design. And again, only one section has currently been evaluated here. That's shown by that block right there. We go to reports, PDF reports. we have a wall design summary report and a wall intersection report. So the wall intersection report, this takes quite a while to generate, but this would show you the schematic view of the reinforcement at each joint. If we produce this summary report, if I do the wall design summary report, the first option, this is just a replicate of the wall design summaries that we produced, during the processing of that one code of that one design section. Okay, now this report could be 100 pages, 200 pages long, just depending on how many sections you've evaluated. Again, here it's just one report for one section. I'll open it up now to any questions. We can take 5 or 10 minutes for questions if you have any. If you don't, again, we'll go ahead and put this up on YouTube. And I appreciate everyone attending today. So I'll go ahead now and look at any questions we have. Does the program consider P delta effects and/or moment magnification for lateral design? The program the program currently does not include P delta. It's a feature that we will be adding for later this year, likely for the 2018 maintenance release or the 2019 version. We're aware of the requirement and working on getting that taken care of. And the magnification is done on the S-Concrete side. Adapt Wall Designer does not do the moment magnification, but S-Concrete does do magnification for specifically for non-sway type conditions. So S-Concrete requires that the analytical tool that is used to process and send forces and moments to its application, it requires that program to either magnify or do second order analysis, and in that case, again, Adapt currently does not do P delta. The next question is, can we model wall openings in the wall? You can. It's not explicit. Anu, the process for it is it basically requires you to build the walls such that you create an opening just by positioning and how the walls are modeled. We do have a video on our YouTube channel. If you go to that channel and type in wall openings, there is a video that talks about how you can model the openings in the walls. But it currently is done just by how the walls are modeled and kind of linked together versus explicit dimensioning inside of a wall that has been modeled. Okay. Other questions? All right. If there are no additional questions, if you do have any, just please feel free to contact us. We can expound on some of the concepts and the things we've discussed today. I realize that we have limited time to get into a lot of the guts or the details. One thing that I will mention very quickly, if you ever want to use the Adapt Wall Designer just as a section designer, kind of as a standalone program, you do have the ability to do that. If we go over to, if you go into the program files for Adapt Builder, in the Builder 17 files, there is an application called Wall Designer, and if you open walldesign.exe, this program can be used to process just individual wall sections. So you could go in and put in the wall geometry, loads, and design. This is the zone and panel reinforcement, and you could calculate or auto-design a section. So this tool can be used by a user almost as a standalone application for wall design. The documentation, we have a pretty extensive document that talks about how this tool is used. So if you're interested in that document, you can always go to the help menu in the program under documentation, and there's a wall design operation and theory manual here that talks specifically about the wall designer. So, and this is the design tool Adapt Wall that can be selected inside of the parameter entries. So that's something that you may want to look at and use as a standalone. But I appreciate everyone's attendance today. Thank you. And if you have any questions, again, please feel free to contact us at support@edapsoft.com. Thank you.